So up until now, we've very much been just accepting functions for what they are. Even when we're in year 11 and kind of at the start of this year, we know how to do them. So you've got functions f of x equals, I don't know, x squared plus 3x. And you can find f of 0, f of 7, whatever, kind of we know how to use this, even f of 2x, remember we replace all the x's with 2x, and so on and so forth. We need to look a bit more in detail about what functions are so we can understand them and know some more terminology. I do apologise, this is going to be a very dry lesson. It's a lot of stuff to write down, some of it can be tricky to understand. Just got to do your best. It does help that the marks for these kind of questions, or they tend to be like an add-on kind of 1 mark, but obviously we need to get those marks as well. So if you can write this down, so functions, a map. So first of all, we're going to talk about mappings. So a mapping is any rule which associates 2 sets of items. Now here's some vocabulary you are used to, but we're going to extend it a bit. So the set of all possible inputs of a mapping is called can you remember what it's called? So the set of all possible inputs of a mapping is called the domain of the mapping. So that's what we can put in. The set of outputs for a mapping, particular set of inputs for a mapping, is called the range. That's what we can get out. So please get those definitions in your book. Pause the video if you need to. So there are 4 different types of mapping. So we're going to look at these in a little bit more detail. The first one is a 1-to-1 mapping. So in these, each object is mapped to exactly 1 image, and each image is the image of exactly 1 object. See, it kind of gets quite fiddly with the wording, but these diagrams, so please copy this diagram down as well. These diagrams do sometimes help. So this is a mapping diagram. So on the left, we've got our inputs, if you like, or what we would call the domain. And on the right is what is going to come out of this, the range. So those are our outputs. So for example, in this mapping, perhaps A maps on to E, perhaps B maps on to G, maybe C maps to H, and perhaps D maps to F. So each one on the left maps to one on the right. So if we think about these numerically, mathematically, say if I've got the function, or say I've got y equals 2x, and I've got my domain and I've got my range, well, anything I have in here, like 2, 0, minus 3, I'm only going to get to one output. So 0 will go to 0, 2 would go to 4, and obviously negative 3 would go to negative 6. So it doesn't matter what I put in, I'm only going to get one output, and all of those outputs in here, everything in the domain only has one thing that is going to have been the input for it. Okay, the next one, a one-to-many. So as you might expect, the names of these are very kind of good clue as to what happens in them. So in a one-to-many mapping, an object may be mapped to 2 or more different images. So we've got our mapping diagram. Please pop this one down. So our domain and our range. So an object may be mapped to 2 or more different images. So perhaps A goes to E, but perhaps also A goes to F as well. Perhaps C goes to G, and perhaps D goes to H, and perhaps B doesn't map to anything. So think about mathematically what you might have something that would do this. So how can you think of anything, a bit like we used y equals 2x in the first one? Can you think of one that would do for this? Well, how about y equals the square root of x? Well, for that, if I've got something like 4, well, the outputs for that, well, I would have 2, but I could also have minus 2. So that is a one-to-many. For every input, there might be more than one output. Next. So many-to-one mapping. So in this case, 2 or more particular objects may be mapped to the same image. So again, I might have A goes to F, but perhaps C goes to F as well. Perhaps D goes to H, B goes to E, but B perhaps goes to G as well. So a many to one. So as you can see, F, I've got two inputs that get me to F. So again, can you think of something that might do this in terms of our maths? Well, how about y equals x squared? Because if I've got my inputs and my outputs, say I've got minus 3 in here, and I've got 3 in here, well, when I put them through y equals x squared, well, negative 3 squared gives me 9, and 3 squared gives me 9 as well. So many inputs, and they both lead to one output. Another one would be y equals sine of x. Because if I've got an input of, say, 0 degrees, 180 degrees, 360 degrees, when I put them through that, they all go to 0. So that's a many to one. The last one, you can probably guess what it's going to be. It's many to many. So an object may be mapped to 2 or more different images, and 2 or more objects may be mapped to the same image. Ugh, so wordy, but it's easier to see it visually. So A might go to E and to G. B might go to F. C might go to G. H might go to E as well. And D might go to H. And obviously the diagram gets a bit complicated. This is a bit more difficult to perhaps think of, but a nice kind of one that we might remember is x squared plus y squared equals 1, a circle. Because, for example, this value for x gives me 2 values for y, and this value for y, well, I've got 2 corresponding values of x there and there. So that's a many-to-many mapping. So why does this relate to functions? Well, this is the definition of a function more technically. A function is a mapping in which there is only one possible image for each object. So think about the ones we've just looked at. So which ones of those would relate to a function? Think about it visually as well with those mapping diagrams. A function may be one-to-one or many-to-one. Now, the way I like to think about these is if I had the graph. If I've got the graph there, it's a bit easier to see. So if I've got a graph, and this is called a vertical line test, I think. If I can draw, so say whatever I've got, whatever, blah, blah, blah. Okay, if I can draw if all the vertical lines only cross one point on my graph, which all of these do, they only cross one point on the graph. Doesn't matter if I go all the way up to infinity or down to negative infinity. Those vertical lines would only would only cross one place on this graph. Okay, so these are all functions. However, as soon as it hits more than one place, so say I've got this, all right, if I draw a vertical line there, I hit 2 places, and that would not be a function. So this would be a function, this would not be a function. So that's like a way that I like to think about it. But the crux of it is a function may be one-to-one or many-to-one. So I've seen a question in a A-level exam which says, why is this not a function? And you would say something along the lines of, it is a many-to-many mapping. Okay, so it can't be a function because it's many-to-many. Or it's one-to-many, so it's not going to be a function. And that would get you like 1 mark. So here are some quick examples. So mappings don't actually just have to happen to, in terms of numbers and those graphs and the calculations and things. We can think about them more kind of with real life examples. So here are some. Here we've got a mapping of a set of children who live in a particular street to the set of types of pets. Well, we can have one child can have 2 types of pets, and any type of pet might have more than one child owning it. So this would be a many-to-many mapping. Here we've got the set of mothers in a toddler group to the set of children at the group. Well, here for every mum, well, there might be multiple children, but in this example, every child has only one mother. Okay, so this would be a one too many. So technically, ignore the rest of that sentence. I didn't have a so technically afterwards. Okay, so here, mapping from the set of children at a toddler group to their ages. Well, again, so you can have like more than one child go to the same age. So look, Chloe and Layla both go to 3, but you can't have one child go to more than one age. So here you would have a many to 1, and that would kind of technically be a function. Here is the mapping from the set of women at a ballroom dancing class to the set of their partners. Here we can hopefully see quite clearly it's 1 to 1. Each woman has one partner at the class, and every man has one woman as their partner. Now, so don't dwell too much on those. It is important. The main thing I want you to take away is to understand what one-to-one, one-to-many they mean, and they're basically in the names. So hopefully that will get in quite easily. And this definition of a function. So on to the next bit of vocabulary.